Nearly 7 miles beneath China's remote deserts, engineers are carving an abyss that rivals the record-breaking Kola Superdeep Borehole, a project launched on direct orders from President Xi Jinping. But China's pursuit isn't just a race for glory. It's a quest to penetrate rock older than 145 million years, reveal hidden forces shaping earthquakes and volcanoes, and seize untapped energy that could reshape the world. Why risk so much, and what secrets might these enormous holes uncover? China's deep drilling campaign begins with 2 sites that push the boundaries of what machines and people have ever attempted beneath the ground. In the Tarim Basin of Xinjiang, engineers have driven a borehole to a depth of 10,910 meters, over 35,800 feet straight down. In the Sichuan Basin, a second ultra-deep well is underway, aiming for about 9,000 meters, or nearly 30,000 feet. These numbers are more than statistics. They represent a direct plunge through layer after layer of rock, past the reach of most scientific instruments, into a world that has remained undisturbed for more than 145 million years. To put the Tarim hole in perspective, its depth is roughly 0.09% of the Earth's diameter. That may sound small, but for a single vertical shaft through solid rock, it is a staggering achievement. The distance from the surface to the bottom of the Tarim borehole is greater than the cruising altitude of a commercial jetliner. If you lowered Mount Everest into the hole, there would still be more than a mile of empty space above its peak. The Sichuan well, at 9,000 meters, stands in a class of its own as well. Both projects are designed to reach geological layers that have never been sampled directly, and both will rank among the deepest holes ever drilled by humans. Only Russia's Kola Superdeep Borehole, which reached 12,262 meters, has gone further. China's engineers are not just chasing records, they are targeting depths that have tested and broken the world's best drilling technology for decades. At these depths, the rock is ancient, the pressure immense, and the temperatures can rise above 180 degrees Celsius. No country has ever attempted to drill so deep, so fast, in such challenging geological settings. The numbers alone set the stage for a new era of exploration, one that demands both precision and ambition on an unprecedented scale. The Kola Superdeep Borehole in Russia set the standard for what is possible and what can go wrong when drilling toward the planet's hidden layers. Over 24 years, starting in 1970, Soviet scientists and engineers drove a shaft 12,262 meters into the crust, farther than anyone before or since. Their efforts did not just push technical boundaries, they upended scientific assumptions. At 6 kilometers down, the team recovered microscopic plankton fossils preserved in rock more than 2 billion years old. Hydrogen gas bubbled up from the depths, an unexpected hazard that forced constant adjustments to drilling fluids. Even more surprising, water seeped from deep fractures, trapped for geological ages and released by the drill's advance. The rock record itself defied prediction. Instead of the expected transition from granite to basalt, the drill bit struck a layer of metamorphic rock, reshaping models of the continental crust. But the greatest barrier was heat. Temperatures at the bottom soared past 180 degrees Celsius, enough to destroy sensors and grind progress to a halt. After more than 2 decades, the project stopped short of its ultimate goal, leaving Kola as both a scientific triumph and a cautionary tale. China's leadership has studied these lessons closely. In 2021, President Xi Jinping launched the country's Deep Earth Exploration Initiative, setting out a dual mandate: advance basic science and secure new energy resources. The official targets are ambitious: reach strata more than 145 million years old, gather data to refine earthquake and volcano models, and open new frontiers for oil and gas extraction. The directive is clear: combine scientific curiosity with national strategy. Where Kola revealed the limits of 20th century technology, China's new campaign is designed to test the edge of what is possible now. The government's push is not just about breaking records. It is about answering questions that Kola left open. What lies deeper, how the crust changes with depth, and whether new resources or hazards wait below. By framing the project as both a scientific and strategic mission, Xi's administration has placed deep drilling at the heart of China's national priorities. The world is watching to see what surprises the next few thousand meters will bring. Earth's surface is only the beginning. The crust makes up just about 1% of the planet's volume. Beneath that, the mantle stretches downward, holding nearly 70% of Earth's mass and over 80% of its volume. At the very center, the core, mostly iron and nickel, accounts for the rest. Mantle convection, the slow churning of hot rock, can take up to 2 billion years to complete a single cycle. Yet for all the knowledge gained from seismic waves and volcanic rocks, no one has ever brought back a pristine sample from the mantle through drilling. Every specimen that has reached the surface so far has been altered by its journey, changed by contact with water or air. The real properties, density, heat flow, and how seismic waves move through untouched mantle remain a mystery. That's why China's engineers and scientists are pushing the limits of what's physically possible. Drilling at these depths means facing temperatures above 180 degrees Celsius, where sensors and drill bits begin to fail. Mechanical stress builds as the weight of thousands of meters of steel bears down on the equipment. Boreholes risk collapsing or veering off course, threatening the entire operation. Every meter deeper means more pressure and more heat, each capable of destroying tools that work perfectly at the surface. Drill bits made from advanced alloys wear out quickly, and even the strongest casings can buckle under the load. Real-time data systems must survive conditions that would fry ordinary electronics. Any mistake, stuck pipe, fluid loss, or a sudden surge of gas can end months of work in an instant. For the teams underground, every hour is a test of precision and endurance. The search for untouched Earth pushes not just technology but human ingenuity to its breaking point. Project Mohole, launched in the United States in 1958, set out to reach the Earth's mantle by drilling through the Pacific seabed, though it never got beyond 183 meters before being cancelled in 1966. The project's engineers invented dynamic positioning, a technology that now anchors every deep-sea drilling vessel in place, even in rough waters. In Germany, the KTB program started in 1990 and pushed to 9,101 meters beneath Bavaria. KTB's legacy is not just depth, but the way its teams stabilized boreholes and tested new high-temperature tools, setting standards for how to keep a well open when the rock itself wants to close it. These breakthroughs didn't just gather dust. They shaped every deep drilling effort that followed, including China's current campaign. The pace in China is something new. Shendi Take 1, the Tarim Basin borehole, officially began drilling at the end of May 2023. The plan called for a 15-month schedule, an ambition that dwarfs the decades-long timelines of Kola and KTB. In reality, the final depth of 10,910 meters was reached in February 2025, after about 21 months. The first 10,000 meters fell in less than a year. The last 910 meters took nearly as long, as the team battled heat, pressure, and unpredictable geology. Wang Chunsheng, chief expert at CNPC's Tarim oil field, led the charge. For Wang and his team, every meter was a test of new alloys, sensors, and real-time data systems, all built in China, all stress-tested in the world's most demanding conditions. But the ultimate prize lies even deeper. Scientists and engineers look ahead to supercritical geothermal energy, a resource that could be 10 times more powerful than conventional geothermal and sits up to 20 kilometers below the surface. The wells drilled so far are only the beginning. If future projects can crack the code, the energy buried deep in the earth could power cities and factories on a scale never seen before. For now, the Shendi Take 1 milestone is a signal. The technology is real, the ambition is growing, and the horizon keeps moving further down. China's Shendi Take 1 well in the Tarim Basin reached 10,910 meters in 2023, making it the deepest vertical well in Asia and the second deepest globally after Russia's Kola Superdeep Borehole. This achievement builds on decades of international effort, from the Kola project's fossil discoveries at 6 kilometers depth to the cancelled American Mohole program. Yet, no drill has ever retrieved a direct sample from Earth's mantle. That barrier remains. China's official documents cite dual goals: scientific exploration and energy security. The project's rapid timeline, 15 months compared to Kola's 24 years, reflects advances in technology and state support. However, many technical details, including full results from the Sichuan Basin, remain undisclosed. As of now, the promise of direct mantle samples and practical supercritical geothermal energy is unfulfilled. What is clear: each new borehole adds to our understanding of Earth's deep interior and the limits of human engineering. The quest to reach the mantle continues, driven by both national ambition and the enduring mysteries beneath our feet.